You're live.
Okay, thank you. Thank you for that, Vincenzo. Good morning. Good morning to everybody. Thank you for attending today's CECIMO hosted webinar on the use of repair in AM. Before I talk briefly about CECIMO and an introduction to today's subject, I just ask everybody to respect the house rules. Keep cameras off, microphones muted, please. Use the chat boxes to post questions during the presentations and the speeches. Once we've had the presentations given by our panelists today, there will be an opportunity to ask questions and participate in the panel later on. I hope that everybody finds today's webinar beneficial. Right, so before handing over to our panelists, I'll just briefly talk about CECIMO, what we do, and about today's subject. So I hope you can all see my screen. So CECIMO, first of all, we're an umbrella organisation founded in 1950 that represents the common interests of additive manufacturing, machine tool and related manufacturing technologies at a European and global level. We are a point of reference for European governments and the EU, as well as industry, on subjects of strategy, leadership and global competitiveness in their application in the fields of economics, technology and innovation. We, for a number of years now, have been giving a voice to the additive manufacturing value chain at a European level, with the mission of promoting the sector, raising awareness for policymakers on subjects that are key to the growth of the European AM industry. And those topics include production capacity, regulatory and non-regulatory barriers, funding from R&D through to production, patents and IPR issues, standardization, certification, and the skills shortage. It's important to highlight that the European Commission launched the Circular Economy Action Plan in March 2020, part of the Green Deal strategy that includes several initiatives that will bring the EU closer and increase overall sustainability in Europe. And this year, the European Commission is expected to launch several new proposals. Among these will be one that aims to give consumers the right to repair goods that they buy, meaning manufacturers should be required to make spare parts for those products available and easily accessible to consumers. At the moment, the goods in question include refrigerators, dishwashers, and televisions. The legislation has arisen due to concerns that goods aren't lasting as long as they could do, with even some environmentalists claiming that devices have been designed with planned obsolescence to shorten their lifespan. This initiative is important, therefore, supported by the European Parliament, who approved in February a report called the New Circular Economy Action Plan. Interesting that in it, the opinion was presented by the Parliament Transport Committee, who highlighted the importance of the exploration of the potential benefits for repair processes of an efficient combination of scanning and 3D printing. And we've already seen, for example, Deutsche Bahn, who've presented at these seminars before, already using these techniques for repair of their rolling stock. Furthermore, across Europe, some national legislative initiatives have already started to discuss and promote the right to repair, ensuring it remains a sustainable and viable activity within local communities. So in Sweden, for example, people can get tax breaks for appliance repairs, and in Graz, in Austria, people can apply for small grants covering 50% of the labour cost of repair. And in France, in December last year, the Parliament voted the anti-waste bill for a circular economy. The bill addresses repair to limit unnecessary replacement of products and therefore production of waste. Further actions on this subject are expected in Spain, the UK, and Italy. Although these initiatives only focus on a limited market segment, they provide an opportunity for both governments and businesses to look at technologies that facilitate product repairing, and they give manufacturers access to different and a more circular approach to product development. Therefore, we believe there is a big opportunity for the whole AM sector to help companies and citizens to increase the percentage of parts and product repaired. Furthermore, different sectors are facing the issue of stocking hundreds of thousands of spare parts. There could be an excellent opportunity to develop new business models which look at digitalization of inventories and distributed manufacturing facilities to provide better service and avoid production disruptions. These opportunities and scenarios do not come without facing some challenges. At CECIMO, we have launched a series of policy and communication activities to promote the AM sector as an enabler for the transition towards a more circular economy. Our mission being to bring AM to the policymakers' attention and promote the sector's contribution to the circular economy debate. In a previous webinar, we've discussed supply chain resilience or product sustainability, and today we are focusing on repairing with AM. So what's today's webinar's aim? The webinar will highlight the role of the AM sector in facilitating the repair, remanufacturing and production of spare parts, leading to a more circular approach to manufacturing, bringing the EU closer to a step to achieve its circular economy targets. AM can make repairs more manageable and cost effective. It allows spare parts to be printed on demand and closer to where they are needed. This reduces inventory, waste, products' carbon footprint, and extends the lifetimes of those products repairing spare parts that would otherwise be difficult to obtain. So today, with the help of our industry experts, we will try and answer some important questions. What are the main steps to consider when deciding to use AM for repairing? How can a company identify the assets that should be repaired with AM? How do we make sure that the quality management standard of the product is respected? What are the costs and savings benefits? What are the business cases available? And can the right to repair regulation speed up the adoption of AM in Europe? Those are the questions that we will be considering with our panelists today. And with no further ado, I'm going to introduce you to our first speaker, Jean-Pierre Jacques Lyon, who's the CEO and co-founder of Marklin. Pierre-Jacques co-founded Marklin in 2020 with Thomas Boulier, enabling manufacturers to qualify and distribute spare parts by producing on-demand and locally used 3D printing. Pierre-Jacques, the floor is yours.
Thank you, Stuart. Good morning, everyone. Yeah, now I see myself. So I'm going to share a short presentation. Can you see it, Stuart? Is it okay?
Yeah, I can see it. That looks fine.
Okay, perfect. So let's go. So good morning, everyone. So my name is Pierre-Jacques, and I co-founded a company named Marklix with the goal to produce spare parts on demand thanks to 3D printing and additive manufacturing. So today, neither additive manufacturing nor blockchain have found their business model alone. And we live in a time of changes, pandemic changes, making industrial supply chain more resilient, regulation changes with circular economy decrease based on European directives, and that's why CECIMO united us today. Also economic crisis with reindustrialization, reduction of dependence on the foreign suppliers, and finally technological changes with the digital transformation that continue. The experiments have been done, and we must now go further to transform the supply chain indeed. To jump into spare parts production with additive manufacturing, manufacturers have to achieve many issues. The first one is the parts qualification with the right choice of material and technologies, but also to have some return on investment studies. And that's why we are building with Marklix a machine learning algorithm, improving all of these processes. Second step, we also offer reverse engineering services with topological optimization, for example. And then it will be possible to create a digital catalog, digital stocks to offer customers an on-demand production. And to do so, we secure all of these transfers thanks to a private blockchain directly connected to the 3D printer, but we will talk about it a bit later. So Marklix Professional allow to identify the percentage of printability of every spare part of a catalog, to guide in the choice of the right process and material couples, thanks to the machine learning we are building, to calculate the economic viability of the process, the return on investment, also to distribute the references on a dedicated white label platform, to manage a catalog of spare parts, to market and access a worldwide network of machine and certified service bureau and service providers. And we can work on topological optimization and 3D modeling. Thanks to the blockchain we are building, we can also create trust between different actors with distinct interests. To manage the intellectual property, the IP, and in the decentralized production, to guarantee the quality of the manufactured spare parts, and finally to invoice remotely the prints and to automate many processes. So by facilitating qualification, distribution, and manufacturing, Marklix makes on-demand production possible. This paradigm shift allows to bypass many strategic issues, like by reducing risk involving the warranties and liability, but also compliance to the new French and European directive we talk about, but also have some benefits by boosting the profitability thanks to inventory and management cost savings, and by reducing waste, reinforcing brand reputation, and improving customer services performance. And that's it for me. Thanks everyone. We can talk about it maybe later. I don't know if we have some question now, or
we'll take questions later,
okay.
Pierre-Jacques. We'll get through the speaking part first, and then we'll be putting some to you. Thank you very much for that presentation. I'm going to move on now to the next speaker, who is Joachim Antonissen, who is the General Manager for Guaranteed. Joachim has worked for 20 years in the R&D department for ArcelorMittal, where he held various positions prior to working as CEO of Guaranteed. Joachim, you have the floor. Thank you very much.
Okay, thank you, Stuart, for the introduction. Just putting it to full screen. Presentation. Please let me know when you see the presentation in full screen.
You're showing the PowerPoint in-app version of the presentation at the moment, Joachim, not the full screen version.
Yeah, well, it's loading, so it's might take 1 or 2 seconds.
There we go.
It should be okay now. Okay,
good,
thank you. Okay, so as a quick introduction to Guaranteed, so Guaranteed is a company which has been created about 2 years ago by the 3 different shareholders, which you see here represented on the top left of the slides, being ArcelorMittal Belgium, Fernandez, and Ocas. And we are really mainly focusing on providing really large scale, so XXL metal 3D printing services to a variety of different industrial sectors, which you see being represented at the bottom left of the slide. Now, as you can see from these industrial sectors, of course, what they all have in common is that they are very often using quite large castings, large forgings as main products or main components in these industries. As a consequence, within Guaranteed, we have decided, at least at this point in time, to focus on using the so-called wire and arc additive manufacturing process. And you already see a small picture of our production installation at the bottom right of the slide. Just to give you a few numbers, in terms of our dimensional capabilities, we believe that we are quite unique, at least on the European scale, but even worldwide. Our production cell at the moment, it's 10 meters by 6 meters by 5 meters, and we're able to handle parts up to 20 tons. So this is really taking additive manufacturing to a bit of a different scale. Now, where we also try to differentiate, it's by providing a full service to our customers, meaning that all the pre-processing, the actual deposition, as well as all the post-processing is done completely in-house, because we feel it's important to offer to our customers a guarantee on the lead time. So this is one aspect which is explaining also the name of the company, Guaranteed. Another really unique feature of the company is that we're also, through our software and through our monitoring capabilities, we're also providing a guarantee on the performance, on the properties of the parts which are being produced or repaired. And especially looking at the different industrial sectors which we are addressing, you can imagine that this is a really important element for these customers. Now, again, what perhaps makes Guaranteed a little bit different from other companies is that from the very first day, we took also a specific focus, not just on producing new parts, but also on repairing existing parts. And this was triggered by the fact that in these industrial sectors that I mentioned, we're often using large castings, large forgings, but when these fail, they very often do not fail completely. And there might be only a fatigue crack in a certain area, there might be an area which is worn too much, but it's actually quite rare that the entire component fails. So being able to repair the component locally brings about a couple of different advantages in terms of cost, of course, but also in terms of lead time, and especially focusing on today's seminar, also, of course, in terms of sustainability, because you can imagine that for a casting of 500 kilogram, having to repair only 50 kilogram as compared to producing the new part completely from scratch, that saves a lot of critical resources in terms of materials, but also in terms of energy. So this brings me to the different value propositions which we are offering as a company, ranging from what we call direct repair, in which we basically do a one-on-one repair, over refurbishment, in which case we might also offer slight improvements with regards to design or with regards to material selection. Because of course, as compared to casting or forging, where you require dies or molds, in additive, we are completely freeform, which means that small changes to the design or small changes to the material selection can basically be done at no additional cost as compared to conventional manufacturing. And then, of course, as a lot of the industrial sectors which we are addressing are quite mature industries, especially in Europe, we're also, of course, offering the possibility to produce new parts from scratch, which can be particularly interesting in case, for instance, of obsolescence, as was already mentioned by Stuart in the introduction as well, where again, we can produce a part on a one-on-one basis, but we could also, again, move to optimization, in which case we are also, for instance, performing lightweighting, we're introducing channels which could be used for cooling or heating, or we could even combine, again, different materials in one production in order to optimize functionality of the part. Now, let me take you to two examples where we make this really concrete and tangible. The first example is the repair of a cast wheel rim, which is used in large transport vehicles in the steel industry. So these rims are a few orders of magnitude larger than the rims which you would find on your Volkswagen Golf or Opel Astra. They're quite a bit larger. A normal person only reaches up to, let's say, about half the height of this type of rims. So you can imagine their size. So then the pictures illustrate typically the process that we do in our company. So we will remove, first of all, the damaged area. In this case, it was a fatigue crack. We fill this area again using new raw material, using our wire and arc additive manufacturing process. And now we would also do the final processing in order to bring the product back to its dimensional tolerances. In this case, the economic savings for the end users were very huge, very substantial. You see here the new part cost 60,000 euros. The repair cost only 5,000 euros. So it's a significant saving. But even more important, perhaps, these rims are only produced in the US. So when a part is required in Europe on the mainland, it actually needs to be shipped from the US to Europe, which of course represents also a substantial amount of footprint, carbon footprints due to that transport. We analyzed also together with the University of Cranfield University, with Dr. Emmanuel Pagone, what was the impact on the energy consumption and carbon emission of producing these rims using conventional production capabilities or repairing them using WAM. And you can see very clearly on this picture that even if we are ignoring the benefits that I mentioned in terms of logistics, in terms of transport, the benefits in terms of energy consumption and carbon emission are really, really huge. Now, a second case that we looked at was the production of a 2205 duplex stainless steel valve, which is also used in the oil and gas industry, where conventional production in this case is a combination of machining and forging.
Joachim, you have 1 minute.
Yeah, the net weight of this valve was around 100 kilogram, which means that you would need around 500 to 600 kilogram of raw material. Using WAM production or WAM repair, we can of course substantially reduce again the amount of material which is needed due to the lower buy to fly ratio. And again, we looked at what are the impacts in terms of energy consumption and carbon emission for the option of producing the entire valve using WAM or just repairing a certain section of it. And again, the results I think speak for themselves in terms of carbon emission, in terms of energy consumption. The option of producing this type of components using our technology brings about very substantial benefits, where these benefits are of course even larger when we are considering the repair option. With that, I would like to come to the end of my presentation, and if there's further questions, I'll be happy to take them later on in the Q&A session, or you can always also reach me on the email address which is mentioned here on the final slide. Thanks.
That's great, Joachim. Thank you very much. Thank you very much for that. Some very nice case studies. I'm going to move on to our next speaker now, please. Daniel Landgraf, who is the Regional Director of EMEA for Link 3D. Daniel joined Link 3D, an additive manufacturing end-to-end MES software provider in 2020 as the Regional Director for EMEA. He has an extensive background in software sales and consulting. Welcome, Daniel.
Thank you very much for the introduction, Stuart. And first of all, thank you to the CECIMO team for having us here. So I also wanted to give a little bit of our overview, what the repairing with additive manufacturing brings for the market. So first of all, to my experience, so I'm in the software industry since over 15 years, around 8 years from that in the additive manufacturing process and workflow consulting software. And in that time frame, I've already also gained a lot of experience in the implementation of additive strategies with companies in various industries. In doing that, we have again and again seen that there are different challenges in the adoption of additive manufacturing into a business strategy. And I think three of the key challenges we need to think about and need to look at is first, where to start. So it's always a question, does it make sense having a conventional part, which I manufacture since a decade in injector molding? Does it make sense to 3D print it as it is, or where do I need to tackle that? How do I find the right applications? How do I find the right parts in order to bring the full value and the full potential of additive manufacturing to my organization? The second point, what we have seen is the development and the standardization of processes and materials. So again and again, just had a call with a large customer yesterday out of the oil and gas industry, complaining that there are still not clear and standardized regulations for the use of additive manufacturing in the spare part sector for the oil and gas industry. We're getting closer and closer. We have companies like TÜV Süd in Germany, like DNVGL globally, or also API, who are working on that, but it's still a path to go. And of course, a point, the cost and the speed of production. So if I have a large scale production where I need millions of parts, additive manufacturing is still tricky. Also, we have in metal, in polymer machine OEM manufacturers who are really working on that area. So knowing these challenges, we also know that AM can bring a large value, and also especially for the right to repair, it can add a dramatic amount of additional value. So the sustainability of the production itself brings the sustainable production, the possibility of sustainable production is one of these topics. Creating digital inventories for spare parts, what we've already heard from Pierre Jacques today, is a value. Distributed manufacturing on demand, which leads to more cost and efficiency, and the reduction of inventory, which brings again the point, sustainable production is a large value which we can implement in this area. So when I was asked what I think about this new right to repair rule, I definitely see the value for manufacturers which are starting to look at additive, implementing strategies and strategies about digital inventories and digital distributed supply chain management. That can be a large benefit for these manufacturers. Still, also in the right of repair, we will come up with challenges. All the positive facts additive manufacturing can bring to the industry. So the challenges still are there. File availability and distribution. How do I make sure that the file comes to the right place at the right time? IP secure transactions, we've heard that as well today. So for each OEM, it's always a big topic. How do I make sure my IP stays with me? Ensuring part quality, leading a little bit into the certification and standardization process. How can I make sure that the part quality is on a continuously base the same? And one of the biggest questions might be, how do I provide parts to the audience? Do I provide them via licensing model to repair centers, and or do I give a fair access for public use of these kind of parts? So we at Link3D see this. We're tackling these topics, these challenges from a digital perspective, looking into enabling OEMs and enabling organizations to have a full digital strategy implemented also for the right to repair with additive manufacturing, starting with creating additive manufacturing supplier networks, where it's, from our perspective, important to have a single source of truth a platform which manages as well the in-house, but also the external production. Creating digital inventories and catalogs where we can provide and store certified parts in order to make them available for distributed manufacturing. We have the IP protection, where we are looking at technologies like blockchain, which can be utilized as the technology's backbone in a digital manufacturing ecosystem. There are also other technologies like from companies like Legalane. Still, there is a long way to go, no matter which of these IP protection technologies we're looking at. Because
Daniel, you have a minute to go.
Awesome, thank you. We need the collaboration between machine manufacturers, software vendors, and OEMs. And the last one, we're working with a lot of initiatives, like I mentioned earlier, on the quality management to really ensure industrial certification standards meet internal and external qualification and audit needs. So that are the topics we're addressing from a digital supply, from a digital point of view. And if we manage as a conglomerate to do that, we're sure that the right to repair is a boost for the additive industry. Thank you very much.
Thank you, Daniel. Very interesting. Much appreciated. Thank you for that presentation. I'm going to move straight on to Manuela Perrone, who's the engineering manager at Avio Aero. Manuela works as an engineering manager at Avio in Brindisi in Italy. I hope I've pronounced that correct, and leads the repair development team responsible for the research and development of additive technologies in the framework of the new European Technology Development Cluster. Manuela, the floor is yours.
Yep, thank you. So I don't know if you can see my presentation.
We can't yet.
Okay, sorry.
There we are. Something. There we go. Yes, so we can see PowerPoint. We're just waiting for it to go into full screen mode.
Yep. Can you see now?
That's great. Yeah.
Okay, perfect. So first of all, good morning all, and thank you for this opportunity. So my name is Manuela Perrone. I'm the manager of the repair development team in Avio Aero. So the Avio Aero journey around additive technology started in 2007. It was boosted significantly when Avio Aero was bought by GE, since Avio Aero is now a company within the GE Aviation Group. And one of the main step related to this additive manufacturing journey is the opening in 2016 of the additive repair center for fully devoted to repair development and for aviation components. So this repair development center is fully devoted again to the repair development using additive technologies for aviation components. So the mission of this lab is, first of all, to develop these additive technologies from a significantly low level of maturation of the technology itself to the industrialization. I used to say that our projects are always significantly and strongly business driven, since when we start a project and we start from, again, a low level of maturation of the technology, we already have on the other end already a component and a specific condition on the component that we would like to repair. How we do this activity? In this activity, in particular on the research portion of this activity, we are strongly supported by a research network. It's GE Research Network with, in conjunction with also other business like oil and gas, healthcare and so on. But also Avio as the chair of the new ET technical development community dedicated to repair. And in this technical community, we have collaboration with several universities, in particular in Italy, but also in Europe. Within this research network of the ETDC, the main partner for our activity is the Polytechnic of Bari. And a witness of this strong collaboration is the fact that the Apulia Repair Development Center is also physically located inside the Polytechnic of Bari campus. We are also supported by six people coming from the Polytechnic of Bari, and also 7 professors, structured professors, support us in, and so we leverage the expertise of these professors. So summarizing what we would like to do, so the main mission of the Repair Development Center is to build new repair expertise and capabilities, but we also would like to be focused on create a business opportunity for Avio Aero, but also GE Aviation repair stations. So which are the technologies which Avio decided to use for this additive repair journey? In particular, we are focused on developing repair by cold spray and laser metal deposition. So the cold spray technology enabled us to introduce already some repairs on housing and adapters of PGBs, so mainly gearbox, which is one of the main products for Avio Aero. And the cold spray technology is enabling us to apply repair on features that have never been repaired before, with complex geometries at fuel interfaces, for example, which are very critical in terms of operations. While the laser metal deposition is enabling us in this moment to develop a repair dedicated to titanium aluminide blades. In particular, this material does not have any technology already developed for the material build-up, and we are using also these technologies and this equipment in this moment to recover some scraps from new make production. In fact, the new make production are from Avio Aero itself in the Cameri plant, and it is an LPT blades manufactured by a powder bed laser deposition machine. So it's also this blade manufactured with an additive technology, but also on already parts already in service with the GNX LPT blades. So one of the first achievements, so the first achievement we got with this within the Repair Development Center is the industrialization, so development and industrialization of the first cold spray repair on a GE Aviation component. If we look at the timeline, after the commissioning of the lab, we started on this project around mid of 2017, developing the technology on specimens and coupons. As soon as we completed the initial setup, we switched to the demonstration of the application of the repair procedure on a component itself. We completed this step at the end of 2017, and then we got the activity of the handover to the Avio Aero shop. this activity was really the first project, but we have here a typical timeline for our project, where the setup on the component is made with a strong collaboration with the component repair and overhaul shop, and this, in our opinion, facilitates significantly the handover to the shop and the industrialization. Industrialization is also significantly reduced in terms of timeline, in terms of risk of failure, and in terms also of increasing and use as much as possible the technology already available in the shop that has the goal to fully industrialize the repair. So, and this is something peculiar for the Repair Development Center. So again, as a big picture, we go from low level of maturation of the technology to industrialization. In this journey, we are supported by our component repair and overhaul shop, and this is something really valuable, in my opinion, for
you have 1 minute left.
Yeah, thanks. So we just can say that the additive manufacturing journey, particularly the repair additive journey, is one of the ways GE Aviation and AvioAero fulfill their purpose by inventing the future of flight, lifting people up and bringing them home safely. So that's all for me. Thank you for your attention, and also from my side, I'm open for any question.
Thank you very much for that, Manuela. I think that's a lovely summary at the end there. We'll get back to you with the questions after we've completed with our final panelist today. I'd like to introduce everybody to Paolo Gregori, Managing Director of Pro-M Facility. Paolo works for Trentino Sviluppo SPA. Apologies for that pronunciation, I've murdered that. The development agency for the autonomous province of Trento in Italy, leading the mechatronic prototyping center Pro-M facility. Paolo, the floor is yours. I can see your presentation. You just need to change from the presentation view to the full screen PowerPoint view.
Okay. Oh, I don't know why, but at the moment something changed.
Try the switching screens option.
Yeah, I know, but I cannot find at the moment. Sorry. We have tried before and everything has worked perfectly.
It's working perfectly. I know how you feel.
Sorry for that. Just a moment.
Paolo, you can go on impostazioni di visualizzazione.
Yeah, I know, but I cannot find this. It's a different visualization.
Okay.
Before.
Then I can share your screen. I can share my screen and present.
Thank you very much.
Tell me. You can. No problem.
Sorry for that. So, thank you very much, and sorry again for the problem. My name is Paolo, and Paolo Gregori, and I'm the Managing Director of the Pro-M facility in Trentino region, Italy. Please, you can go on. I'm here, and thank you for the invitation. I will present what we are working on about repairing damaged objects from industry and through hybrid manufacturing. Please go on. We are in, as I said, in Trentino region, so a very small region in the north part of Italy. We have an autonomous province, and we have invested a lot in new technologies and innovation. And in 2017, we started a new lab for prototyping mechatronics systems. So we are not only focused on additive manufacturing, but for us, additive manufacturing is one of the enabling technologies for realizing prototypes. We invested quite a huge amount of money from regional development funds from Europe. So at the moment, about 7 million euro in machineries. We have about 2,000 square meters of for our industrial lab and about 20 people staff. We are focused on additive manufacturing, metal, polymeric, and hybrid. Hybrid means, in our case, additive and subtractive together. We have also a specific area for metrology, so we have fully a machine that can perform X-ray computed tomography in metrological way. And we have an area for reverse engineering with 3D scanners and CMM. But we can also perform mechanical testing and and climate chamber tests. We have also competencies in software development, artificial intelligence, and electronics. So every technology that can be useful for prototyping mechatronics. Please. Just a picture of our team, because I will present also a specific demo case that we are starting up into the Vanguard initiative 3D printing pilot. So this is our team. It's a quite transversal team, because I'm a physicist. I have full support of the University of Trento through the professor of industrial engineering, and we have a number of colleagues that can help us to manage the demo case in the Vanguard initiative. Please. So what we are performing at the moment, so the rationale of the demo case in the Vanguard initiative is how to repair objects from industry, objects that have an added value cost. So how to repair something from industry is quite a difficult task, because it's a focus of this webinar, because it's still handmade, skill dependent, not so much repeatable, and hybrid manufacturing at the moment, so subtracting and additive together can be a solution. You can see in the slide a picture of a specific machine that we have in our lab that can combine additive and subtracting together. And but it's not only a matter of machineries, it's a matter of competencies, and also it's a matter of developing a state-of-the-art software that can lead the process in a proper way. So CAD/CAM process is still very, very demanding at the moment. Please. So the main target application are at the moment dies and molds for foundry, hot stamping, CFRP fabrication, and also let's say wear-prone components for energy industry, in particular, for example, Pelton turbines. Target technologies can be hybrid machines like ours, so they can combine 5-axis milling machine and direct deposition of metal together. But we can compare this approach with others like WAM technology, a previous presentation has shown, and also lens. Our technology readiness level is quite high, from 6 to 8, so we are very near to market. At the moment, we are developing the technology in order to be very efficient and very effective in terms of demo case and specific activities for industry. Please. The technical approach to repairing in our case is combining different technologies, starting with a 3D scan of the damaged object, a comparison between the CAD model using a specific approach called OC3. If someone is interested in details, I can go deeper in the technical approach, but it's not the case at the moment because I have no time by now. So I will go on and I say that we have to add the new material where it's missing and restore at the end the original shape by a milling machine. Targets are...
Paolo, you have 1 minute to go.
Yes, okay, so you can go on, please. And I would like to conclude with this minute with some industrial applications. So development of mechanical special parts, repair of injection molds by reverse engineering and direct energy deposition or equivalent technologies, please. And as you can see, we are the starting point of this technology and development an approach where we can repair damaged objects, and also we can put a multi-material objects on that, like copper on stainless steel, or a mix of different powders and different materials. So I can conclude with my last slide, please. And I can say that we are starting up a new demo case in Vanguard initiative. We are running research and development activities in order to extend the material portfolio that we can use. We are enhancing a network of competencies within the pilot, and we are approaching industrial applications that are quite interesting at the moment for industry. We are looking also for further use case, and so we are very welcome if someone of you are interested to go deep into details of this approach. Thank you very much for your attention.
Thank you, Paolo. Thank you very much for that presentation. Some nice case studies there. We will now move on to the panelist question and answer session. So if the panelists don't mind putting their cameras on for this, please, so we can all see you. I'm going to start with Pierre-Jacques Lyon, if possible. Pierre-Jacques, a question that I have for you is regarding your platform, the fact that it addresses most of the products that fall within the scope of the Right to Repair initiative. We often hear policymakers' concerns about the impact of 3D printing on intellectual property rights law. Could you tell us a bit more about why you believe blockchain is the right solution to solve this problem?
So basically, what we propose is to allow manufacturers to produce parts by proposing a network of service bureaus according to the qualification or algorithm I've made. So the 3D file goes from the manufacturer side, owner of the IP, to our platform, and finally to a service bureau. So there is two sensitive moments when the IP could leak. It's in the Marklix side, in our servers, and in the service bureau. By using the blockchain, we can protect the file in our servers with encryption. So it's much more harder to hack. And we don't send the 3D file directly to the service bureau. We send the encrypted file to the service bureau, and the blockchain I talk about, it's directly connected to the software of the 3D printers of the service bureau. So the service bureau don't have access or any access to the APU or the 3D file, but just access to the operation and the processes and the orientation of the part in the machine, etc., is completely locked by the blockchain, and only the software of the machine can unlock and start the print. So the IP is not accessible. Okay, thank you very much for that answer. You're welcome. I'm going to move on to Joachim and Tonison now. Joachim, if we take the oil and gas or the railway industry, what would help companies in these sectors modify their ways of behaviour, their business models, to adopt an on-demand production or repairing with additive manufacturing capability?
It's indeed a very relevant question, I think. In our opinion, so far, what we see is that it's really important that the entire value chain, the entire ecosystem works together on these things. I think especially when we focus, for instance, on the oil and gas industry, I think the most straightforward or obvious customers, direct customers for a company like Guaranteed would be the OEMs who are providing the parts to the end users. They are, of course, today used or accustomed to a business model in which they are filling warehouses with spare parts. And that, of course, needs to shift under the impulse of the end users to a completely different business model, where parts are being produced only when they are really needed, or let's say only within a certain time frame before they are actually needed. I think this is really requires a shift of the mindset of everyone involved in the value chain. So I think we really need to bring all these different partners together in order to have, on the one hand, the drive, the pull from the end users, on the other hand, also the willingness from then the OEMs to move to this different type of business model, because in the end it will benefit, I think, everyone. But there's a kind of like always in change, there's a hurdle in between that we need to overcome, and I think this will only be done when we all work together on this.
Okay, thank you for that answer. Daniel Landgraf, if I can move on to you now. Does the right to repair push more companies in the direction of additive manufacturing, do you think? And if so, what support do you think companies need in order to adapt their production?
It's a very good question. I think on the one hand, yes, it will push more companies, more OEMs into the adoption of additive manufacturing. On the other hand, it also allows organizations who have already implemented additive manufacturing, working on new business models, working on new business cases, to really justify the investment into additive. What do they need to support the adoption? I also see two main points there. First of all, there is a let's say we as an additive industry, we need to continue the education for additive in order to ensure that the people really understand where the value comes from and how they use this value. And on the other side, and that is a little bit of combination also on the first question, which Pierre-Jacques already answered, if it comes to IP protection, blockchain, or which technology you're using for these IP protection. We need to ensure that there is a collaboration, not just between the OEM and the customer. Also, there needs to be a collaboration between software providers like Pierre-Jacques, Marklix, us, and the machine manufacturers in order to ensure that the process really works in the correct way.
An interesting point to end on there. Thank you very much for that response. My next question is to Manuela Perrone. Manuela, what we wanted to ask you was, what are the most common issues and benefits that you've experienced when with repairing with AM? Is it all good?
It's always interesting, I can say. So, I mean, the level of maturation of the technology, as I mentioned during the presentation, is not so high. So at the beginning, we need to face all the issues related to such condition. For example, we don't have powders developed dedicated to core spray or to laser metal deposition, and we are also working on this. So we are developing and designing also the powders. This is one example. Or, for example, the other point is how each process parameters can influence the result of our and the quality of the deposit. Sometimes we learn from our design of experiments that something that was not taken so much into account before has to take into account, but has to be taken into account since it's significant. So for this reason, I say that it's always interesting. The main benefit is related to the fact that we now are capable to recover something and to recover hardware which cannot be recovered up to some months ago. So complex features, but totally new materials like the titanium aluminide.
Okay, thank you for that.
Thank you.
This brings me to my my final question for this session. And Vincenzo, I don't know if you've got any questions from the floor that you might want to put to our panel once I'm done, but I'm just going to move on to Paolo Gregory now. Paolo, in the Vanguard initiative that you mentioned briefly at the end of your presentation, you talk about regional initiatives team to tackle some important R&D challenges within the AM sector. Do you think that regional initiatives can have a multiplier effect in the adoption of 3D printing for local business?
Thank you for this question, quite demanding, from policy makers.
It wasn't me that wrote it.
I can say that for sure, a regional initiative and local businesses are strictly connected. I think that our activity is could be seen on three different levels. One is obviously the value of the transnational cooperation in European networks. So putting together investments and capabilities in a European network in different regions. But for sure, there is also a sort of embedded possibility of the additive manufacturing to be dislocated in different areas of production, running, let's say, data instead of vehicles. So there is also an embedded advantage using additive manufacturing in working in different areas. So it's also a matter of sustainability and also reducing emissions. And also companies can locate this kind of competencies and machineries together with the industry. So again, we can perform additive manufacturing or hybrid manufacturing, repairing activities near and close to industry in a diffused network. And so I think that it could be a new approach also in supply chain, and new approach in repairing activities in a diffused network.
Okay, thank you for that, Paolo. Thank you very much.
Thank you.
Before I move on to my summing up and closing this webinar today, is there anything you'd like to add, Vincenzo?
Yes, well, indeed, I've seen that some of the speakers were quite active on the Q&A. I would say that many of the questions were already answered, but I would say maybe I'll just follow up with Paolo, and maybe extend the question to the rest of the panel, because there was one of the participants asked you, did you certify any repaired parts or the process? And I think this was addressed also in another question from one of the participants. How do we assure in general the quality of printed parts, and how can companies or entities can support the approval of and the certification for highly regulated industries? Paolo, maybe you can start.
This is a very good question. I've already answered that it is a goal for us. It's a goal of our demo case. So we are now performing testing and quality assurance, but we are not at the moment ready for a certification. So one of the goals of the demo case is indeed the certification of the results. But at the moment, what we are performing is very promising in terms of performances, and so we are very open in cooperation and collaboration on this direction.
Thank you. Maybe Manuela. So we go the reverse order from what we had before.
Yep. Let me just see if I can. Can you hear me? No. Yeah. Okay. So from my perspective, we assure the quality of our repair in two ways. The first is we have a repair readiness level process. It's a phase and gate process through which we start from, again, low level of maturation of the technology to industrialization. And this involves all the technical experts, so design, material engineers, but also business and supply chain. This is from design and development. As soon as during this phase, we use for sure specimens to demonstrate that we are within design and material engineering requirements. And then we have the standard process control peculiar for these technologies that we established during the development phase. And with these additional controls, we keep under control also the production phase. So the principle, the rules are more or less the same of the standard process, but for sure we need to customize for these new technologies. And the level of details that we, also the numbers of specimens and controls in this moment are greater for sure than the standard process that we know very well, like I don't know, thermal spray or standard TIG welding and so on.
Okay, thank you very much for that answer, Manuela. I think that draws us to a conclusion today. Before I thank everyone for spending the time with us, I just wanted to summarize. I thought we saw some really great case studies today, and thank you in particular to Guaranteed for sharing not only the technical intricacies, but also the cost benefit and also the environmental benefit. That was very, very interesting to see. There is a theme through the technology, which is in terms of repairing castings, although as a friend and colleague from SLM has pointed out in the questions and answers, other technologies are available. I genuinely believe that the use of AM technologies for repair is one of the major applications, and it's great to see not only the technology moving on, but also the systems and the infrastructure around it, particularly what we saw from Link 3D and also Marklix. The use of IT to guarantee the supply chain and the IPR is something I think is a very interesting development in the industry, and one that will help it in its maturity. I think it will leave it there for today, but thank you very much again to all concerned, everybody attending and everybody participating. Thanks once again, and I hope to see everybody soon on the next CECIMO AM webinar. Thank you all again. Cheerio.